Well, hello everyone. Good afternoon and welcome to our virtual tour of outer space. Now, if you are a regular viewer of our program, you may notice I'm not Josh. Josh is away today, so I am filling in for him. My name is Mary, and I'm going to be taking us on a tour throughout our solar system today. And if you have any suggestions of where we should go throughout the tour, feel free to put those in the comment box, and I will do my best to fulfill your wishes. But we're going to bring up OpenSpace now. And I am starting us out, not quite in outer space yet. I decided we would start pretty close by to where I am. I'm missing the Academy of Sciences. So I started us right above Golden Gate Park. You can just see the music concourse right over here, and the California Academy of Sciences is right there. And if this is your first time joining us, we've been bringing you these virtual programs ever since the shelter in place started in San Francisco. And this is a show that we would normally give in the Morrison Planetarium at the California Academy of Sciences. But thankfully, we're able to bring it to you in your homes as well. And we are using OpenSpace, which you can get at home too. You can download it on your own computer and fly around space yourself. And one of the cool things about this software is that it uses real recent data sometimes. Real data always, sometimes recent data. So what we're looking at as we zoom out away from San Francisco and away from the Bay Area, we're going to start to see some clouds popping up. And those are from actual photographs and satellite imagery from just 3 a.m. this morning. I think it updates every single day. So those are recent clouds that we'll see as we zoom out. And I apologize if it's a little jerky on our way out. This little laptop I have is struggling a tiny bit, so I apologize for that. But you may see, looks like we might be able to see some smoke from the fires that we've been having recently over here in California as well. And we've had some pretty wild weather. We had some thunderstorms the other day in San Francisco, which is very unusual. And I'm hoping to bring us to a place that has had its own thunderstorms recently. But we can look around our lovely planet for a second. And something that I'd like to do with any tour of the solar system is to kind of think about what we're looking at and think about how Earth-like is this place. So Earth, of course, I would argue, is the most Earth-like place. And there's lots of reasons for that. We can look around our planet and see a lot of different aspects like water, an atmosphere which we can breathe. We see continents and land and all sorts of different features that we can think of as being unique to our planet. But there are some of these Earth-like features that we can find throughout the solar system. We'll see if we can find some today. But before we visit some but some places that definitely have Earth-like features, I'm going to take us to one of my favorite spots in the solar system, what is sometimes called our sister planet. So you might think this place is Earth-like. And for a long time, people did think it was very Earth-like. Venus. When people looked up at Venus, for a while they thought that perhaps it was very much Earth's twin, perhaps a tropical paradise version of Earth. Since Venus is around the same size as Earth, and it's a bit closer to the sun, so hey, why not? Why wouldn't that be a lovely place to go? But relatively recently, within the last, maybe 100 or so years, we've gotten a lot more in-depth information about Venus with the spacecraft that we've been able to send there and our much more advanced telescopes that we have here on Earth as well. And as we began to learn more about Venus, we found, nope, it's actually a horrible, horrible place. You never want to go there. It's terrible. And there's a few reasons for that, because the only Earth-like thing about it pretty much is its size and the fact that it has rocks. One thing that's not very Earth-like is that while it does have an atmosphere, this atmosphere we're looking at is extremely thick and made of mostly carbon dioxide, so it's really hot on Venus. Though it feels hot for me here today, but 80 degrees Fahrenheit is nothing compared to the hundreds and thousands of degrees Fahrenheit that you have on Venus. It is so hot you could probably cook a pizza within just a couple of minutes. And even if you get rid of that horrible and hot atmosphere, the surface doesn't look much better. I'm not seeing any oceans of water. I'm not seeing any plants or anything that would be habitable for us humans. So while this is our sister planet, it is certainly not a place I would want to go, and not a place I would think of as being very Earth-like. Oh, and we have a question. Excellent. Do I have a favorite moon? That is an excellent question. I am tempted to say that the moon is my favorite moon since it's our moon and it's our closest neighbor, but there are some other moons out there that I do really like. I think I'll take us to one. Let's go over to Jupiter and we can visit Europa. Now, Europa is one of my favorite moons because it's really interesting. It has some Earth-like features like water, though not water on the surface. We have not found any water on the surface of any planet or moon yet, at least not lots of liquid water. We've found some really, really salty, not great water on Mars, but that's about it. But on Europa, we think that there is an ocean of liquid water underneath the surface, and not just a little bit of water. We think it has more water than all the water that we have on the Earth, which I think is pretty fascinating. And we didn't know that until relatively recently, too. As we started to get some better images of Europa's surface, we can see all these cracks on the surface, showing us that there's motion going on underneath, and there's an ocean of liquid water causing all those cracks that we see on the surface, which is pretty cool. So Europa is definitely one of my favorites, and another reason it's one of my favorites is because it's also around one of my favorite planets, which we can fly over to for a second as well. It is one of the moons of Jupiter. So let me focus on Jupiter here. And I'm using this opportunity to shamelessly put forward my idea for what my favorite feature on Jupiter is, what it's called. Now, I know that several different names have been thrown out there, but I'm going to say right now that it is Jupy McJupiter face or Jovi McJo face. And if you mix up those, it's just incorrect in my opinion. You have to have the similar names together. Jovi McJo face is my favorite. But this is a group of storms in Jupiter's clouds. Jupiter has a lot of storms, and this one is right below the most famous Jupiter storm, the Great Red Spot. But right over here we have our derpy Jovi McJo face group of storms. And all these storms that we see, the circular ones like the Great Red Spot and the eyes of Jovi McJo face, are kind of similar to hurricanes like we have here on Earth. And the Great Red Spot has been happening, we think, for hundreds of years. Galileo, over 300 years ago, may have seen the same exact storm through some of the very first telescopes. But it has been shrinking. Some more recent news about Jupiter is that it's been shrinking pretty rapidly over the last few years. So we'll have to keep an eye on the Great Red Spot, see if it's going to stick around for another few hundred years. Let's see. How are the number of planets determined around other stars? Ooh, that is an excellent question. So how are the other planets around other stars, exoplanets? Let me see if I can bring up our exoplanet markers here for you. So it sometimes takes a couple of times to click this button. So all these blue markers that we're seeing here are showing us the location of stars that have at least one exoplanet, a planet around another star. And the way that we determine how many planets are around other stars depends on the star and it depends on the exoplanets. So some of these we've been able to find 1 or 2 exoplanets, but some of these have 3, 4, some have half a dozen exoplanets around those stars. And it really depends on a lot of different factors. Where are those planets when we're trying to look for them? Because one of the ways that we find exoplanets is by looking for a transit, planets going in front of the star and blocking out the light of the star so we can't see part of it. So looks like we have, sorry, one second. But yeah, so it depends on how easy it is to find those exoplanets in the first place. Sometimes they're in a position where you just can't see them very well, and you end up seeing only 1 or 2, even if there might be more than that around the star. So varies a lot. But I'm going to take us next over to somewhere in the asteroid belt that I very recently learned about some also possibly oceans of liquid water that I didn't know about until just a few days ago. I was chatting with my family and my father was saying, oh, Ceres has some new news. Ceres is an ocean world now. And I was like, that can't be correct. He must have said the wrong place. But he was correct. Ceres, we think, does have some liquid underneath its surface. So it's a brand new member of the kind of ocean worlds that we have throughout the solar system. So as we've visited Ceres in the past, I know Josh has come to Ceres several times in this program, we can look for these salty deposits on the surface. So if we look at this crater over here, you can see those white areas there. And we only recently, with the Dawn mission, learned of this. So the Dawn mission orbited around Ceres and took lots of pictures for us. And we were not quite sure what these were for a long time or what caused them. And we began to learn what they were made of, but still didn't know what they were caused by. And very, very recently, NASA announced that they're caused by liquid that had evaporated out to the surface and left behind some salty deposits. And they think that liquid is still there. They think that an ocean of brine, so really, really salty water, about 25 miles deep and hundreds of miles wide, is underneath the surface of Ceres, which is bananas, in my opinion. I had no idea that Ceres might have that underneath its surface. And to give you an idea of how much water that is, I looked it up real quick because random numbers mean absolutely nothing to me. I looked up how deep Tahoe is. Tahoe is only about a half of a kilometer deep, whereas this we think is about 40 kilometers deep. And Lake Michigan is also about half a kilometer deep, but pretty big. So think of this as a really, really deep Lake Michigan underneath the surface of the biggest dwarf planet in the asteroid belt. Well, the only dwarf planet in the asteroid belt. Pretty interesting, in my opinion. All right, we got another question here. What can you tell us about the egg-shaped dwarf planet Haumea? Ooh, that is a wonderful question. And unfortunately, not a whole lot. I do know that Haumea is a dwarf planet, and that it's one of the few, half a dozen or so dwarf planets that we know of in the solar system. But I honestly don't know a whole lot more details about Haumea besides that. I apologize. But perhaps I can look that up, and in a future show we can talk more about Haumea. All right, but if anybody has any more suggestions of where to go, let me know. I'm going to take us over to Pluto next in the meantime, which is another one of our dwarf planets. And I'm curious if anybody out there, if you're watching and you want to chime in the chat box, if you have still been wondering why Pluto isn't a planet, let me know. Because I've asked that question quite a bit when I give planetarium shows. How many people out there are still wondering why Pluto isn't a planet? And there are a lot of people that are still to this day asking me about that and wondering why Pluto isn't a planet. And I'm here to tell you, it's not that scientists hate Pluto. I don't hate Pluto. I love Pluto. I think Pluto's great. But it just has to do with where Pluto is in the solar system. So it's really far out. It's way out in the Kuiper belt, farther out than Neptune or Uranus and all the other planets in our solar system. And it's not alone. For a long time, hundreds of years, we thought that Pluto was all alone out there. Well, not hundreds of years. We haven't known about it that long. But for the time that we did know of Pluto, we thought it was all alone, floating around in space, all by its lonesome. But in the late 90s, early 2000s, we started to find a lot of other objects around the same area as Pluto in the solar system. And as we made that discovery, we had to adjust our understanding a little bit and say, well, do we want to add on half a dozen or so more planets, or do we want to come up with another category for these objects that we're finding? So, long story short, some scientists came up with a new category of dwarf planet, which is an object that is round like a planet that goes around the sun, but it has a messy orbit, it has a lot of stuff in its orbit. So Pluto is now the biggest of the dwarf planets, the king of its realm. And I love to visit Pluto because it has a beautiful, beautiful surface. We're looking here at a great plain of frozen nitrogen. We're seeing some water ice mountains. It has nitrogen snow. It has an atmosphere that varies throughout its year, and it's blue, which is beautiful. And it's just a really, really pretty place. And we didn't get any of these pictures until a few years ago when the New Horizons spacecraft flew really close to Pluto and took them for us back in 2015, I believe. Keep trying to throw out numbers and then second guessing myself if the numbers are correct. So don't come at me if I get a number incorrect. All right. But we can also see over here in the background is Charon, Pluto's biggest moon, which I will argue that the thing we should really be talking about is not whether or not Pluto is a planet, but why isn't Charon a dwarf planet as well? They should both be dwarf planets because they orbit around each other. Charon does not just orbit around Pluto like a lot of the other moons in our solar system. So that's my plug for what should be different about Pluto. What is the temperature of empty outer space? I couldn't tell you exactly a number because, again, I don't want to say the wrong number, but it is very, very cold. I know that the surface of, or rather the clouds of some of the outer planets like Saturn and Uranus and Neptune and Jupiter, they can be -200, -300 degrees Fahrenheit. And that's not even just the vacuum, the empty space in between things. And that can be a lot colder as well. So very, very cold, negative hundreds of degrees, depending on how far away you are from objects like planets and the sun. All right, I'll wait to see if anybody has suggestions of where else to go. Or if you want to go back to a place. I'm moving kind of quickly here. So if you want me to go back somewhere, feel free to let me know. I'm kind of bouncing around quite a bit. But I've taken us over to what might be my second favorite planet, aside from the Earth. Earth is my favorite planet because we live here and I like it here. But Jupiter is my all-time favorite because it has a lot of interesting clouds. It has a lot of interesting moons. But Saturn is the prettiest planet, in my opinion, because of its beautiful rings. And it's just really nice to look at through a telescope, too. It's one of my favorite things to look at through a telescope because you can see the rings. And I've often had people say it looks like a sticker because of how clear and like realistic it looks at, like even with a small telescope. And these rings, there's been some relatively recent news coming out about Saturn's rings as well. I talked about earlier that the great red spot on Jupiter is probably disappearing, and we'll see if it sticks around for hundreds of years. I don't know. The rings on Saturn also haven't been around quite as long as we used to think. Now, we do think that they've been around for millions of years, which of course sounds very, very long in our human terms, but it's very possible that they hadn't formed yet maybe 70 million years ago. Now again, that sounds extremely long, but think about this. If somehow dinosaurs were able to have telescopes and look up at Saturn, they would not see rings. And it's possible that in a few 100,000 years, these rings aren't going to be here anymore. So we live in a really unique, wonderful time that we can see Saturn how we do today with its beautiful rings, making it, in my opinion, the most beautiful planet in our solar system. All right, so we've got several more minutes here. Talking kind of fast, I apologize, but I'm going to take us to another moon. We're going to pop back on over to Jupiter, and I'm going to take us to one of my other favorite moons. While Europa is one of my favorite moons, Io is also one of my favorite moons, so we're going to go over there. Has there been any further discussion about the rings of Saturn being the remains of a moon in orbit of Saturn? That is a wonderful question. I believe that, I'm trying to remember the latest on that because it has changed over time what the leading idea is for how exactly the rings formed. I don't think it used to be a moon that was like broken up in any way. I think it was made around the same time as Saturn, but if anybody if I have any co-workers in the comments or if Bing wants to chime in on that one, feel free. But I haven't heard any super recent updates on that, but I am curious to know about that too. I can look that up after this. Thank you for bringing it up. I do know that they're made almost entirely of water ice, which I didn't know until a couple of years ago, which I thought was pretty cool. And there's almost snow basically in the rings as well. But I've brought us over to Io, which is one of the Galilean moons around Jupiter, and one of the 4 biggest moons around Jupiter, and one of the closer moons to Jupiter as well. So it's being pushed and pulled by the gravity of Jupiter, heating up its insides, making a lot of volcanoes on its surface, which makes it a very interesting looking world. all of these strange sulfury volcano areas make it look like maybe pizza. I always like to say it looks like moldy pizza. This does not look like very appealing pizza to me, but we can see that on the surface of Io. What makes a moon a Galilean? Very good question. So the 4 Galilean moons were first recorded by Galilei, the astronomer, over 300 years ago with some of the very first telescopes. People like to say that he was the very first person to ever use a telescope. That's a little iffy, but he was one of the first people to create and use telescopes. And he used his telescopes to study the moon, to study Jupiter, and he was the first person the first recorded person to observe these 4 largest moons around Jupiter. And so they were named after him because he was the first person to record it and share it widely, that Jupiter did have moons. And that's one of the things I like about the Galilean moons as well, is that it was a very early on discovery that there were these other worlds out there, and these other planets had moons going around them. It wasn't just us, and that the moon itself was its own other world. All this stuff we didn't know until a few hundred years ago, which is pretty wild. All right, but I'm going to bring us back closer to home. Let's stop on at Mars before we go all the way home. Why not? We have the ability to fly wherever we want in the solar system. And Mars is also a very, very beautiful planet. I love looking at Mars. And in OpenSpace, it's really fun too, because you can see a lot of detail on the surface of Mars as well. See the giant canyon and the largest volcano in our entire solar system. So that's one of the things I like about Mars, is it has some of the biggest land stuff in our entire solar system. So I'm going to bring us over. Let's see if we can find Marineris Valley. And I'll take us to Olympus Mons as well. All right, I might need to turn off the nighttime side of Mars here. There we go. So I turned off the nighttime side of Mars. And we right now are right above Marineris Valley, which is a gigantic canyon. This canyon could span across from New York to San Francisco, roughly, if it was here on Earth in the United States. Someone's trying to get into my house. I don't know what's going on there. And it's very deep as well, about 6 times the depth of the Grand Canyon, if I'm not mistaken. And over here, we have right next to this gigantic canyon, the largest volcano. I think somebody got locked out of my house. The largest volcano in the solar system, Olympus Mons, which is about 3 times the height of Mount Everest, the tallest mountain on the entire planet. All right, well, if there are any other suggestions on where we should go, let me know real quick in the comments. Otherwise, I'm gonna start heading back on home to Earth. And I do want to thank you all for joining me for our tour of outer space. I hope you enjoyed flying around with me. Let's go back home to Earth. I don't want to leave you stranded out here in the middle of space. And if you're interested in more space in your life, we have several regular programs that go on throughout the week. Tomorrow, Bing will be talking about what's up in the night sky. So he'll be giving our weekly night sky tour. That's at 1:30 p.m. Pacific. On Fridays, we have our Cosmic Conversations, where we have scientists and experts come and talk about what they do, or talk about different recent findings in astronomy. And on Tuesday mornings, if you have little kids in your home, I do a show for little children on Tuesday mornings at 9:30 a.m. Pacific, either about the moon, next week is Moon Explorers, or about shadows, Shine and Seek. So be sure to check those out as well. And looks like we have one last question here about sunrise on Mercury. I'm not sure exactly what that question is getting at, but I do know that the sunrise on Mercury would be very extreme because Mercury is very, very close to the sun compared to us. Also, Mercury has no atmosphere, so there would be no atmosphere at all blocking any sunlight whatsoever. And Mercury's days are really long too. It takes a really long time for Mercury to rotate, and it goes around the sun really fast. So I believe its days are very, very, very long as well. So that's what I know about sunrise on Mercury. But with that, we are back home to our own home planet Earth with all of its Earth-like qualities that we saw at the beginning of the show. And with that, I want to thank you all for joining me today, and I hope you have a wonderful rest of your day. Stay healthy, stay happy, stay sane, and I'll see y'all another time.